In this lesson, we're going to revisit the TVM solver, but this time show that it works with present value annuities as well. So if you want to visit this TVM solver, there's the link for you there, the same one we used in the previous lesson. I'll just bring it up. There it is right there. Then we can get started. Okay, so in this first example, we're looking at Michelle's grandparents. So they're going to help her with her college education. So the situation is Michelle's about to head to college, and let's pretend that all her tuition and residence and stuff like that is paid for. And so Michelle's grandparents are going to help out. They're going to take a bunch of money and they're going to put it into a savings account, like an annuity, and that money is going to collect interest at 3.5%. And what's going to happen is at the end of each month, some of that money is going to be transferred into Michelle's account. So a grandparents or parents might want to do this as a way to sort of not give someone all the money at once, but just to provide, with some sort of like helping them by budgeting, so they only get money at the end of every month. Okay. So the first question is, how much money would need to be invested at the beginning of Michelle's first month of college to provide her with $300 per month? So the idea is that there'll be some big sum of money. Okay, and Michelle's in college for 3 years, which is 36 months, and there'll be 36 equal monthly payments of $300. So, I mean, if we just imagine this annuity, you could go $300 times 36. That's the amount of money that Michelle gets, but it doesn't take that much money to give it to her because the money gets to collect interest. Some of the money's collecting interest for more than 2.5 years before she finally needs it. So we could use the present value formula to solve for this one and just go PV equals and write that whole formula out because we have our R value and everything we need. Or I want to show you that we can use the TVM solver. So let's do the TVM solver solution here. Okay, so in this one, our payments are $300. Okay, our future value is actually 0. At the end of this annuity, there is no more. I'm going to zoom in a bit for you. There is nothing left. And so we have a, so we have a 0 there. Okay. The present value is what we're looking for. We know the interest rate was 3.5%. It is monthly and 36 months or 36 periods. We can solve for the present value. And that gives us the answer of $10,238.18. Now notice that in this case, the payments were positive and the present value is negative. And the reason we think of it that way is the payments are something that is being received and the present value is something that's being invested. So really, in order to do this, Michelle's grandparents would need to put this amount of money, this $10,000 into the account right when Michelle starts school. She'll then get to collect $300 a month from that for 3 years. So that, of course, is our answer, 10,238.18. Okay. Now, as for the interest that's earned, well, the interest would be equal to the amount of money she collects, which is actually $300, 36 times. Okay, that's going to be more than $10,000, and the reason it's more is because the money collected interest. So subtract that to give you the total interest earned. Sorry, this has turned into a bit of a mess. But you should get $561.82 in interest. So by investing the money, it's like her grandparents saved over $500. Okay, if we continue with this sort of same situation, we can play around with the TVM solver and answer some other questions. So suppose their grandparents are like, whoa, we don't have that kind of money. We only have $4,000. Well, now what monthly payment could Michelle receive? Obviously not $300, it's going to be a lot less. Let's see how much. So back into my TVM solver, I now know, I don't know the payments. I do know the present value. They can only afford $4,000. That's that lump sum. How many, what will she be able to get? We click the payment button, $117.21. TVM solvers are pretty powerful because they can be used to solve anything. So for example, maybe they put this money into an account let's say $4,000 again for part C. So we'll say $4,000. And suppose it's a little bit different because now Michelle has access to the money whenever she wants, and when she's not using the money, it's collecting interest, and she withdraws money, then she can withdraw money. So suppose the end of every month, Michelle takes out $250, okay, which is more than 117. Then the question is, how long will the money last if she does that? So we can answer that using the TVM solver. We just throw in a payment of $250. Now we do need to get this right. One of these has to be negative, one has to be positive. Probably should be the payment. And now we just end up solving for time. And we get 16.4. So 16 months she'll be able to do that. Okay. Or you could say 16.4. But what that basically means is after the 16th withdrawal, there's less than $250 left. So she has 16 withdrawals plus a little bit at the end. Okay, so it's a TVM solver. Just like with future value, you can use the TVM solver for present value. It's almost always the case, though, that your future value is 0. Okay, unlike when you're doing future value and your present value is 0. Okay, thanks.